Okay, so today we're starting rationals for 30-2. It's our last unit. We're in week 9 of 12 weeks, so there's 4 weeks left, and we literally just do rationals for the next 4 weeks. This week we are going to be doing, we start off with reviewing reviewing factoring, and then we're going to go to non-permissible values, and then that's our first lesson, and then our second lesson is going to be simplifying rationals. If you were in 20-1 last year, you would have done these already with complicated trinomials. We don't factor trinomials, which is 3 terms, so like product sum or decomposition. We don't do that in 30-2. If you were in 20-2, you would have seen this as well because we also went over it with you guys too, but we went over it with you not with trinomials. So it shouldn't be new to everyone, but you may have probably forgotten it since it's been a while. Okay? I need to make sure that you guys are watching the podcasts and following along because I'm seeing that some people perhaps are answering not the same way you're taught on the podcasts. So that lends me to believe that perhaps you're using some sort of, app. So if you are, you guys, that's just going to harm you in the future. Not helpful, okay? So there are quite a few people who are watching the podcast, and I'm loving that. If you're someone who's like, yeah, I've been kind of skipping that and copying off someone else or maybe using an app, that is not productive or helpful for you, okay? In the end, yeah, you may come out with a good mark, but you won't know anything. Okay, so the way I am, and you guys are all important to me. I want you guys to learn, and I want you guys to do really well. Okay, so please watch the podcasts in their entirety. I know they're long. I know I am not riveting. I know I'm kind of boring and somewhat monotone, but please watch them. They will help you. Okay, that's all I ask of you. Once again, I want to tell you guys, I miss you as usual. I wish I could be near you guys. I wish we could be in class again, but we're not. So we're going to keep doing this. And you have 4 weeks left, so just push through, okay? The first 3 weeks are going to be the first 3 weeks of the last 4, man, I'm making no sense, are going to be of rational content. The last week is going to be a review assignment, which can replace any bad assignment you've done online. Okay, so if you didn't do a good assignment online, you didn't try very hard, or maybe you did try hard and it just didn't work out because it's online and it's not what you signed up for. Totally fine. If that's the case, the last week assignment will replace your lowest assignment. Okay, so if you do better on it, it'll replace it all, and it's going to be a little bit of a review. All right, so we're going to start off with reviewing of factoring. The first thing we do when we have factoring is we look if we can take out a greatest common factor. So if there's something I can take out of everything, that's the very first thing you're going to do. And then after that, you're going to look for difference of squares. And that's it, because we don't have trinomial factoring in 30-2. Can someone give me a whoop whoop? Yeah, it's awesome like that. I'm super cool. I know. Don't be jealous. All right. So the first thing we're going to look for is greatest common factors. Is there something I can divide out of everything? And then we'll look for difference of squares. And if you're like, what in the heck is difference of squares? That's okay. We're going to review it. You will know. All right? I got you here. Okay. So this one here says example 1, factor. Whenever you're asked to factor, you must always check for a GCF, greatest common factor first. Okay? So I look at these 2 terms. And I have 2 terms. And I say this one has 25D5. And this one is 45D4. What's the largest? So this one has 5 Ds, that one is 4 Ds. So the largest amount of Ds I can take out is 4 of them. I can't take 5 out because 45D4 only has 4. So I know I can take a D4 out. So I'm going to put that. Now, what can I divide out of the numbers? So 25 and 45. What's the largest number I can take out of both of those by division? Okay? The largest number I can take out is a 5. So the greatest common factor I can take out is 5D4. So equals 5D4. And when I take that greatest common factor out of 2 terms, I should still have 2 terms left in the brackets because I'm just simplifying those 2 terms, but they're not going away. All right? So 25D5, if I take a 5 out, 25 divided by 5 is 5. And then D5, take out 4 D's. I'm left with 1 D, so just a D to the 1, or just D, plus 45 divided by 5 is 9. D4 out of D4, I took out all the D's. So that's it. Do that in black. So that's it. I have 5D4 equals 5D plus 9. Okay? Now the 5 and the D4 are attached by multiplication symbols, so if I want to, and this is what I'm going to hazard you to do for all the next 3 weeks, is I'm going to put the 5 in its own bracket, the D4 in its own bracket, and then the 5D plus 9 in its own bracket. And it's factored. Nothing more I can do to that. We're done. Okay, with B, I look at it and I say, I have a 9K4 plus a 12K3 minus a 6K. Now, I have K4, K3, and a K to the 1. If it doesn't have an exponent, it's a K to the 1. So the largest I can take out is just 1K, because if I take out anything more, I can't take it out of the last term. This one has 3 terms. Then I have a 9, a 12, and a 6. What can I take out of 9, 12, and 6? What can I divide out of there? I can divide out of 3. So I put the 3 and I put an equal sign in front of that. So I take a 3K out of each. So I'm taking it out of 3 terms. I should have 3 terms left when I'm done. So I'm going to take 3K out of 9K4. 9 divided by 3 is 3. K4, take out a K, I'm left with K cubed. Then a plus sign. Then what can I take out of 12K cubed? Well, 12 divided by 3 is 4. K3 divided by K means I take 1K out, so it's K squared, because you subtract exponents when you common base. Then a minus sign, and then 6K to the 1. So 6 divided by 3 is 2. K divided by K cancels all the K's out, and I'm done. That's it. Because I'm not factoring trinomials. All right. So 8x squared plus 10x. So what can I take out of x squared and x? Well, I can take out 1x. What can I take out of, I don't ever leave myself enough space, it seems. What can I take out of 8 and 10? Well, I can take a 2 out of both of them. I can divide a 2 out. So I'm GCFing out 2x out of 2 terms. So in the brackets, I should still have 2 terms left over. 8 divided by 2 is 4. X squared divided by x. So I have 2 x's and I take 1 out, so I'm left with just x. Plus 10 divided by 2 is 5. X divided by x cancels. And I can put the 2 and the x in their own brackets after. Okay, because they're just multiplied. I can't separate the 4x plus 5 because a plus sign or a minus sign basically sews those 2 terms together. So they're in their own brackets. But when you're attached by a multiplication sign, like a 2 and an x, I can put those in separate brackets. All right. 12y minus 16. I can't take a y out because the 16 doesn't have a y. But I can take a 4 out of both. So I GCF for greatest common factor out of 4. 12y divided by 4 is 3y. Minus sign, 16 divided by 4 is 4. And that's it. If I look at E, I have negative 15d5 plus 45d3. I can take out a d3 because that's the largest I can take out of both. And out of 15 and 45, I can actually take out a 15. So I can take out a 15d3. Now I'm left with negative 15 divided by 15 is 1. d5 divided by d3 is d2 because you subtract the exponents. Plus 45 divided by 15 is 3. d3 divided by d3, that's it. And I can go 15 in brackets and d3 in separate brackets because they're attached by multiplication sign. And then negative d squared, I don't need the 1, plus 3 in its own bracket. And they're added with a plus sign, so you can't separate them. They're stuck together. Okay, we'll do F together again, and then you're going to try the other ones. Oh my goodness, it's not letting me. Okay, 13a plus 20d. I can't take 20b, sorry. I can't take an a or a b out because it's not in both. And 13 and 20 have nothing in common, so that's actually as low as it goes. You can't take out a greatest common factor. G, what could I take out? I can take a c out. I have c cubed plus c squared minus c. I can take out a c out of the three terms. So c cubed, take away a c, take it divided by c is c squared. Plus sign, c squared divided by c is a c. Minus sign, c divided by c is 1. So if you ever take the same value out, you're left with a 1. Now I have three terms, and in the brackets I should still have three terms. So what if instead I had given you this? C cubed plus c squared plus c. Say I gave you that question. Well, you would take a c out, and you would be left with c squared, and then c squared divided by c is plus c. And then c divided by c, people think it goes away. But remember, if I take a GCF out of three terms, I need to have three terms, don't I? So you don't just go away, which is the common error 101 that happens. You actually get a plus 1. And how can you check if you didn't mess up your GCF? Well, if you put it back in, you should get the same thing back. So if I distribute my c in, I get c cubed plus c squared plus c. So I know I didn't make a mistake. So when you're doing GCFs, you can actually backtrack and check to see if you got it right. Okay. H, I have 6n squared minus 30n plus 42. Not all of them have a variable, so I can't take an n out. Variable being a letter. But I can take a 6 out. So if I take a 6 out of 6n squared, I'm left with n squared minus 30n divided by 6 is 5n. And then plus 42 divided by 6 is 7. And that's it. You can put the 6 in your own brackets too if you want. That's it for that one. I, negative 7m squared minus 10m plus 17. I can't take a variable out because each term doesn't have a variable. And I can't take a number out because there's no number that I can take out of 7, 10, and 17. So there's no number I could take out. But because it starts with a negative, I can actually always take out a negative 1 even if it started with a positive. But in this case, I can take out a negative. So don't forget that a GCF option could be a negative 1 out. So I can go negative 1. And then if I take a negative 1 out, it just changes the signs of all three terms. So I'm going to get a positive 7m squared plus 10m minus 17. Now J, I did it again. I have 18p cubed minus 63p squared minus 9p. Now you can try these out as you go along. Just pause me, try it out, see if you get the same answer. Pause, try it out, see if you get the same answer. So I want you to do that the whole way along till the end of this page. Okay, so right now you would pause it and you try J by yourself. And then you'll play and you'll check and see if you got it right. So 18p cubed minus 63p squared minus 9p. I can take a p out, 1p only, and a 9. Because 9 is divisible into 18, 63, and 9. So I can take a 9p out. 18p cubed, when you take 9p squared out, 18 divided by 9 is 2. P cubed, take out a p is p squared. Minus 63 divided by 9 is 7. P squared, take out a p is p. And then minus 9p divided by 9p is a 1. And if I want to, I can write it as 9 in separate brackets, p in separate brackets. And then the 2p squared minus 7p minus 1 has to be in its own bracket because the 2p squared is sewn to the 7p is sewn to the 1. These minus signs and plus signs sew those terms together, so you can't separate them with plus signs or minus signs or brackets. Okay? All right. So you're trying k on your own. I have 18x squared minus 50y squared. So I can actually take a 2 out. That's it, because the variables are different. 18x squared divided by 2 is 9x squared. Minus 50y squared divided by 2 is 25y squared. Now, this is what we're going to lead to into the next lesson, difference of squares. So in order to have a difference of squares, you need to have a perfect square here, a perfect square here, two perfect squares with a different sign. So we need a subtraction sign in between. How do we know if they're perfect squares? Well, if I take the square root of 9x squared, I get 3x. I don't get a decimal. If I take the square root of 25y squared, I get 5y. I don't get a decimal. And I have a difference sign in between. So if when I take the square root of the two terms, it has to be two terms, and I don't get a decimal, and there's a subtraction sign in between, it's a difference of squares. So what happens? The 2 just gets rewritten, and this actually factors. The 9x squared minus 25y squared factors into two factors. You get a 3x at the front of each bracket, a 5y at the back of each bracket, and in order to not get a middle term, like these two just have two terms, you have to put a plus sign in the middle of one of them and a minus sign in the middle of the other. You can bracket your 2, and you're done. All right. L, our last one on this page. 100z to the 9 plus 50z to the 6 minus 75z to the 5. So the largest I can take out is a z to the 5. And then I have 100, 50, and 75. So I can take a 25 out of each of those. If I take 25z to the 5 out of 100z to the 9, I'm left with 4z to the 4. Plus 50 divided by 25 is 2. Z to the 6 divided by z to the 5 is z. Minus 75 divided by 25 is 3. Z to the 5 divided by z to the 5 is 0. And I can rewrite it with the 25 and the z to the 5 in their own brackets because they're attached by multiplication sign. And then the 4z to the 4 plus 2x, or 2z minus 3 is as good as it gets. Okay, so that's mainly taking out GCFs, or greatest common factors. The next step is factor by difference of squares. So we already looked at one example of that. We're just going to look at a whole bunch more. So here are the steps required for factoring a difference of squares. Step 1, decide if the four terms have anything in common. Called the greatest common, decide if the terms, I don't know why it says four terms, sorry. Decide if the terms, not four terms, that's a typo. Decide if the terms have anything in common called the greatest factor, GCF. If so, factor out the GCF. Do not forget to include the GCF as part of your final answer. So whatever you take out has to stay in front of the brackets. Every difference of squares problem can be factored as follows. ax squared minus bx, or b squared. A squared minus b squared. Oh my goodness, guys. Okay. It equals, you square root the a squared and you get a in the front of brackets. Square root the b squared, you get a b at the end of the brackets. And then you need a plus or minus sign. So it can be written like this with the plus sign first, or like this with the minus sign first. It doesn't matter. Just that they have to be different signs. And that's it. So let's look at the first one. We have to first be able to spot that it's a difference of squares. So in order to be a difference of squares, it has to have two terms. This is two terms. It has to have a different sign. This one does. Okay? So two terms with a different sign. And then I also have to be able to take the square root of both of them and not get a decimal. So the square root of b squared is b. The square root of 64 is 8. So that's good. So there's two terms, different sign, take the square root of both of them and don't get a decimal. So I'm going to get, in the front of both brackets, b, in the back of both brackets, 8, and then a plus or minus sign. And it doesn't matter. I could have written it like this, b minus 8, b plus 8, and it's still the right answer. Okay? Let's look at b. In order for it to be a difference of squares, one term, two terms, different sign, and we have to make sure that if we take the square root of them, we don't get a decimal. Square root of a squared is a, Square root of 144, if you type in your calculator, is 12. So I'm going to get a plus 12, a minus 12 as my two factors. Once again, you could have a minus 12, a plus 12 in that order. It wouldn't matter. All right. We have 9a squared minus 121. So I have a one term, two terms, minus sign. And then I have to check. Square root of 9a squared, 3a. Square root of 121 is 11. No decimals, so we're good. So it's going to equal 3a in the front of both brackets, 11 in the back of both brackets, and a minus plus sign or a plus minus sign. That's a difference of squares. So you can try the last ones and see how you do. Pause and then check and see if you get them right with me. So right now I would pause and do D. So I have one term, two terms, minus sign. Square root of x squared is x. Square root of 81 is 9. No decimals, so I have a difference of squares. My difference of squares is going to be equal to x in the front of each bracket, 9 at the back, plus or minus. E. For E, we have 324a squared minus 289. So we are going to check. Do I have one term? Yep. Do I have a second term? Yep. Do I have a minus sign? Yep. And then we go, the square root of 324 is 18. Square root of 324a squared is 18a. So that's good, not a decimal. And then the square root of 289 is 17. No decimals there, so I'm going to go 18a plus 17, 18a minus 17. F, 81 minus m squared. All right. Two terms, 81 and an m squared. Square root of 81 is 9. Square root of m squared is m. So I'm going to get 9 minus m, 9 plus m. And that's it. Most people don't spot the 1 as being a perfect square, but 1 is a perfect square. So whenever there's a 1, people often won't notice it's a difference of squares, so watch out for that. 25x squared is 5x. And the square root of 1, ooh, that doesn't look like an x. The square root of 1 is 1. So I'm going to get 5x plus 1, 5x minus 1. And you should be super pumped because we don't have to do trinomial factoring. Okay, H. The catch with H is most people will see difference of squares. I'm going to show you how you guys would do it normally. So the square root of 4x squared is 2x. The square root of 36 is 6. And you're going to give me the answer 2x plus 6, 2x minus 6, which isn't wrong, but it's not complete. You would actually have to take a 2 out of each of them, and you'd get a 4 in front. So that's why I've said before in the previous little snippet with GCFs that the very first thing you should do is not check for a difference of squares. The very first thing you should do is check for a GCF. So, what can I take out of 4x squared minus 36? I can actually take out a 4. And then I'm left with x squared minus 9. And then x squared minus 9 is actually a difference of squares. So the 4 is going to carry down, and I'm going to get 2 brackets for my difference of squares. The square root of x squared is x. Square root of 9 is 3. You get plus or minus. So I'm expecting you to show all this work, guys. If you're not showing the square root part, you're not showing what you're doing here, then I'm expecting that you probably didn't watch the podcast. Okay, so I want to see the steps that I'm doing because I need you guys to follow them along so you know exactly what you're doing so you get everything right. And I need to see work shown on all of your assignments to get full marks. All right. Last part of lesson 1. Okay, rational expressions. So we're going to deal with non-permissible values, NPVs, or they're called restrictions. They could say non-permissible values or they could say restrictions. Now, what the heck is a rational expression? That's what we're going to be dealing with. A rational expression is when you have something over something, so a numerator and a denominator, and at least the minimum, one of them has a variable. So like 1 over x plus 6. That would be a rational expression. Now, where does the problem lie? Well, if you end up with a variable in the denominator, we don't know what that number is. It's just a variable. It could be a 2, it could be a 7, it could be a -1, it could be 40. It could be whatever we want it to be. All right? But there is a number when there's a variable in the bottom that it can't be because there's a rule. The rule in math is that you cannot, I should write cannot, not just divide. The rule is you cannot or can't, it's not wanting to give me the apostrophe, divide by 0. What does that mean? The denominator, which my daughter literally just learned about in grade 3 math. She started doing fractions and she learned about numerators and denominators last week. How do I know? Because I'm now her teacher. And her real teacher sent it to me, so I had to teach her about denominators and numerators. So the denominator, which is taught in grade 3, I guess, is the bottom of the fraction, and it can't equal 0. It's another way of saying what I said above. Okay, so for this example where I have x plus 6, what x would be bad that would cause this denominator to be 0? Well, x, if it equaled -6, what would I get? -6 plus 6, and my denominator would actually equal 0. That's a problem, because in all math, no matter what math we do, x cannot, or the denominator cannot equal 0. So our non-permissible value is actually going to be that x cannot equal -6. Okay? So we're going to go through how to find that on an easy way. So, steps to finding NPVs. Factor the denominator. You can factor the numerator as well, but if all I ask you to do, which for this lesson, that's all I'm going to do. The second lesson, it's not going to be the same, but for this one, that's all I'm going to ask you to do is to find non-permissible values. In order to find them, you actually have to factor just the denominator because that's all we care about. The numerator can be 0 because you can go 0 divided by 7. That's 0. You just can't go 7 divided by 0 in your calculator. It's going to give you an error. All right? So just the denominator can't equal 0. So you're going to factor the denominator. First, you're going to look for a greatest common factor, and then you're going to look for a difference of squares. And then you're going to set each of them equal to 0 and solve for it. So let's see the steps. So example 1. Consider the rational expression x plus 1 over 5x squared minus 5x. So I'm just going to look at the bottom there. I'm going to have an x plus 1 in the top. And in the denominator, and that x plus 1 is actually in its own brackets together because they're sewn together with that plus sign. So brackets are imperative to not mess up this unit. Okay, so that's my biggest push is to make sure that you use brackets. Now, the denominator, I look for a GCF first. So 5x squared minus 5x. What can I take out? I can take a 5 out of both terms and an x. Now, I have 2 terms here, so I should still have 2 terms once I take my GCF out in the brackets. So 5x squared, take out a 5x, I'm left with 1x, minus sign, and then what's 5x divided by 5x? It doesn't just go away. Remember, 5x divided by 5x is 1. So when you divide it by itself, you get a 1. That's where your error is going to be. If you don't watch this podcast, you're not going to see that you have to get that 1. Or if you do watch this podcast, please star it because that's the error. The error is not putting the 1. Now remember, we can check back and see if we're right. So I can distribute it in. 5x times 1x is 5x squared. 5x times -1 is -5x. So I can check to see if I'm right. Now what else did I tell you? I told you that this 5 and x are multiplied together so they can go in their own brackets, right? But the 1x minus 1, or you could just write it as x minus 1, has to be in a bracket together because they're sewn together with that minus sign. Now to figure out the NPVs, you take each bracket separately off to the side and you set it not equal to 0. Okay, so to get those non-permissible values, I'm going to take the 5 first because that's my first one. I'm going to go 5 cannot equal 0. Well, that's true. So that doesn't give me an NPV because 5 is a number, not a variable. So that's not a problem. The 5 will never be a 0. So that's good. Then I take my next bracket, which is x. X cannot equal 0. I'm done. X can't equal 0. If x equaled 0 and I plugged it into this equation, remember you can check your NPVs, right? So if I plugged it into my denominator, if I plug 0 in, I get 5. That doesn't look like a 5 at all. Looks like a 3. So I'm just checking my NPV to make sure I'm right. So I'm just plugging it into the denominator. And if it equals 0, I'm right. If it doesn't equal 0, I'm messed up. So I'm going to go 5 times 0, bracket 1 times 0 minus 1. So I get 5 times 0 times negative 1. 5 times 0 times negative 1 is 0. So I'm right. My denominator would be 0 if I plugged in a 0. And that's why you take each of these brackets separately, because if you can make any of these brackets be 0, you'll make your denominator be 0. So my one non-permissible value is x cannot equal 0, and then I need to take my last bracket and set it not equal to 0. 1x minus 1 cannot equal 0. And I have to solve for x. Add 1 to both sides. 1x cannot equal 1. Divide by 1. When you cancel those out, they don't go away to 0. Those canceling lines are actually a really large 1. See, look, really large number 1. So x cannot equal 1. And if I plug 1 back in, it's going to make this bracket over here. If you look, you can find me squiggling over here. It's going to make that bracket be 0 because 1 minus 1 is 0. And when I multiply 5x times 0, I'm going to get a 0. So that's my other non-permissible value. So I often write NPVs. If this was a diploma, I would write non-permissible values. I would not do short form. NPVs R. X cannot equal 0 and 1. Because if they equaled 0 and 1, my denominator would be 0 and I'd be in trouble. Now B says to state the restrictions on the variable. So what the variable cannot be, that's what restrictions mean. That's just another fancy way of saying non-permissible values. So it's the exact same answer, actually. So if they ask you for restrictions or non-permissible values, that's the exact same thing. So the restrictions are x cannot equal 0 or 1. Okay? Oh my goodness. All right. Example 2. Determine the non-permissible value restrictions, because that's the same thing, right? I just said that. For each of the following expressions. So I'm just going to look at the denominator. The numerator can stay whatever it is, that's fine. So 3a minus 1 in brackets, because it's attached by minus sign, over a minus 1. Can I take anything out of it? No. Is it a difference of squares? No, because a and 1 are not difference of squares. So I actually can't do anything to it. I just have an a minus 1 in the denominator. So in brackets, a minus 1, because they're attached because of the minus sign. So the only bracket I have in my denominator is a minus 1. So when I go to do my NPVs off to the side, I take each bracket separately, set them not equal to 0, and solve for x. Well, I only have one bracket. It's a, I'm not supposed to write it in bracket though. Nope. It's a minus 1, and I set it not equal to 0, and I solve. So I'm going to add 1 to both sides to get a by itself. A cannot equal 1. And I'm done. It's the only non-permissible value. Now I check it. 1 minus 1 equals 0. Yep, I'm right. Okay, I'm going to look at B. I just look at the denominator here. So what can I do to my denominator? 2k squared minus k. Well, I can take a k out. So I always look for GCFs first, remember? So I can take a k out. And so I take a k out. I'm left 2k squared divided by k is 2k. Minus sign. And then k divided by k is 1. And then the k is in its own brackets. So I have a bracket with a k in it and a bracket with 2k minus 1. And so I'm going to get two non-permissible values because I'm going to do them off to the side. Each bracket separately. So I'm going to go NPVs. And I'm going to go k cannot equal 0 because that's in this one bracket. And that one's done already. So when it's just a single variable by itself, it's easy. Set it not equal to 0 and you're done because it's already solved for k. Then I do my second one. tk minus 1 cannot equal 0. Then I'm going to add 1 to both sides because I have to get k by itself. So I get 2k equals 1. And then I have to get k by itself. So I'm going to divide by 2. And I get k cannot equal a half. So you could leave them separately like k cannot equal 0 and k cannot equal a half, but I always put them together. K cannot equal 0, comma, a half. And then I box it. Let's look at C. So I'm just doing non-permissible values, so I only care about the denominator, so I'm just going to work on it below. 2m plus 10. The first thing I have to do is say, can I take out a GCF? I can take out a 2. 2m divided by 2 is m, plus sign, 10 divided by 2 is 5. So it has a 2 in its own brackets and the m plus 5 in its own brackets. So when I go to do NPVs, I'm going to have 2 cannot equal 0, which is true, but doesn't get me an NPV. That's my one bracket, so that's okay. Because the bracket has to have a variable in order to get an NPV, which it doesn't. And then I do m plus 5 cannot equal 0. Subtract 5 from both sides. M cannot equal negative 5. So my only non-permissible value is m cannot equal negative 5. Then I'm going to go to D. D is x squared minus 49. So I can't take anything out of x squared minus 49. There's no GCFs. But I have to check. So first thing I do is I check for GCFs. Then the second thing I do is check for difference of squares, which this is actually a difference of squares. Because the square root of x squared is x, and the square root of 49 is 7, and there's a difference sign in between two terms. So in the denominator, I'm going to actually end up with x plus 7, x minus 7. So I'm going to get two non-permissible values because I have two brackets. So my NPVs are going to be x plus 7 cannot equal 0. Use that one. And then my other one, x minus 7 cannot equal 0. The catch is I have to solve for x. So I'm going to subtract 7 from this side. I'm going to do this one first. And I'm going to get x cannot equal negative 7. That's my one non-permissible value. And then I add 7 to both this side. And I go x cannot equal 7. And you can leave them separate like that, or on the diploma and my own self, I would write it as x cannot equal plus or minus 7. Okay? Next page. So we have 4 more. I want you guys to try these ones on your own. They're your turns. Determine the non-permissible value restrictions in the following rational expressions. So you're going to try these on your own, and then you're going to unpause it and check to see if you got the same as me. So right now you'd pause it. All right. So I say, what GCF can I take out of my denominator? I can take out a 2 or a negative 2. I'm going to choose to take out a negative 2. And then when I take a negative 2 out of negative 2x, I'm just left with positive 1x. Minus 4 divided by minus 2 is actually a plus 2. So I'm left with negative 2 bracket x plus 2. So those are my two things I'm left with in my denominator. So when I go to do my non-permissible values, I take my two brackets and set them not equal to 0. So I'm going to get negative 2 cannot equal 0, which is true, but doesn't get me an NPV because negative 2 doesn't have a variable with it. So if it's just a number, like I said, you don't get a non-permissible value or a restriction. And then x plus 2 cannot equal 0. Subtract 2. X cannot equal negative 2. And there's my non-permissible value. I only have one. Okay, if we look at B, I can't take a GCF out of a squared minus 81, but I do spot that it's a difference of squares. Square root of a squared is a. The square root of 81 is 9. So in the denominator, I'm actually going to get x plus 9. X. A plus 9, a minus 9. And so I get, for my non-permissible values, my NPVs, I'm going to get a plus 9 cannot equal 0. And a minus 9 cannot equal 0. Then I'm going to solve them separately. So I'm going to subtract 9 from both sides to get a by itself. So I get a cannot equal negative 9. And then I add 9 to both sides. A cannot equal 9. So a cannot equal plus or minus 9. C, I have 4p squared minus p in the denominator, so I'm going to take a p out, because I check for GCFs first. When I take a p out of 4p squared, I'm left with 4p minus p divided by p is negative 1. And the p is in its own brackets, so when I go to do my NPVs, I have two sets of brackets, so I'm going to have two NPVs, unless one of the brackets just has a number in it. So I'm going to do p cannot equal 0. That one's done. And then I do the other bracket, 4p minus, in a dead zone on my iPad. 4p minus 1 cannot equal 0, because that's my other bracket. And I'm going to solve for p, so I'm going to add 1. So I get 4p equals 1. Divide by 4. Didn't change colors, sorry. P cannot equal a quarter. So we get p cannot equal 0, comma, a quarter. D, I can take a 2 out, and I'm left with x squared plus 4. Now this is actually not a difference of squares. People will think it is because they take square root of x squared, you get x, square root of 4, you get 2, and they'll say it's a difference of squares. But it's actually not a difference of squares. It's an addition of squares. Okay? So when we go to do our non-permissible values, we'll say 2 can't equal 0, which is true, but not a variable. And a difference of squares, you can do. An addition of squares, you can't factor. This will not get you any NPVs, because no matter what you fill into an x squared, for x, and you square it, you're going to turn it to a positive. So whenever you see an addition of squares, not a difference of squares, an addition of squares, you have no NPVs. Okay, so that's all there is for today. We just went over factoring and non-permissible values. There's going to be homework. You can go check in Google Classroom. Your homework will be there. Please try out the questions in your textbook, and then you can do the assignment questions that pertain to this, and then watch lesson 2, which is on simplifying rationals. I hope you have a wonderful day. You're on week 9. You're very, very close to being done, so don't peter out. Just keep working. Okay? Miss you guys.